Okay, so to carry out geometry optimization, you need your optimized compounds. So let's say, for example, these are the compounds we are working with. So you can see that this is the Gaussian input file and this is the Gaussian output file. So the input file is the one you sketch the compound in. So there is no information in this file, but after optimization you're going to see information in the file. So optimization is going to give you the log file which you extract your data from. So you can see that there's information here. So the first analysis we'll be carrying out is the geometry optimization analysis. So for geometry optimization, you record the bond length and the bond angles. So for example, we are going to make use of a Word document. So for example, I have this compound and I want to carry out geometry optimization. So I'm going to have a table first to list out my compounds. So I'm going to have compounds, then I'll have A, B, C, D, and E, depending on how many compounds I have. So let's say this is compound A. Let's say this is compound A. So we are going to open the log file, open the output file, which has been optimized, and we are going to take bond lengths and bond angles. So we can see that this compound has carbon, nitrogen, hydrogen, and oxygen. So we are going to select some bond lengths and represent them on our table. So the first you can see is the carbon to oxygen. If you want to view the labels, right click view symbols. Yes, so you can see which elements you are clicking on. So carbon to oxygen. So carbon to oxygen is 1.22584. So I'll round up to 3 decimal places. That's 1.226. So I would record this on my table as carbon to oxygen 1.226. So the next bond the next bond label I record is my carbon to nitrogen. So carbon to nitrogen, record carbon to nitrogen, and the value is what, 1.39958 here. Well, I'm going to record 1.400. Yes, because we have 99 at the end, so 1.400. So that would be 1.400. So the next one I'll record is the nitrogen to hydrogen bond. That's 1.009. That, or you say 1.010 if I round up. Yeah, that's nitrogen to hydrogen 1.010. Yes, so this is the bond length. And now for bond angles, if you are interested in recording bond angles, you have to select 3 elements, 3 atoms. So 1, 2, 3. Nitrogen to carbon to oxygen, and the bond angle is 122.09629 degrees. So if I'm to record this on my table, that will be like this. nitrogen, carbon, oxygen. So nitrogen to carbon to oxygen. That's 122 point what? 0.096. So yeah, 122.096. 0.096. Yeah. Don't forget to your SI unit in Armstrong. Don't forget to put the SI unit here in Armstrong. So if I'm to record another bond angle from this compound, let's say nitrogen, carbon, nitrogen, for example, 115.6228. So nitrogen, carbon, nitrogen, that's nitrogen, carbon, nitrogen. We have 115 degrees 0.628. So this is your geometry optimization represent, like how you represent the data. I hope you understand.